We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello students, I am Dr. Vidhi Khanduja working with SAL Education. I will be discussing about very important concept in C programming, that is functions. In this presentation, I have tried to include all the essential and crucial concepts related to functions which are normally asked in exam. So please listen and make the notes of all the slides in this presentation. First, we will begin with understanding the concept of functions. What are functions? Why we need them? Followed by types of functions. Then, we will see various elements involved in user-defined functions. Let us consider a situation where you are given a complicated task to be performed. It is very difficult to complete this task from beginning till end at one shot. So what you can do? Obviously, you will divide the task into smaller manageable subtasks. Each of these subtasks can be separately tested and connected together to get my entire task done. These subtasks can be considered as functions. So, what are functions? They are self-contained block of code that perform a particular task. You all are familiar with main, which is nothing but a function. The program can create their own function depending upon the task assigned to them, or they can use the functions which are already existing, provided by some other source, such as C libraries. Consider a situation where you have one main program P1 which uses the function F1, F2 and F3. So, while writing a code, wherever it is required, it will invoke the function and get the task done. So this main function is referred as the calling program, and these F1, F2 and F3 are known as the called function, right? So they exist independently. So main has called them, right? These functions F1, F2, F3, they act as a black box. That means it takes some data from main program and returns a value. You can see, as I explained through the arrow, this information, this data is going from main to F1, and in turn F1 is returning some value back to main. Similarly, F2 and F3. Right? The inner details of functions are invisible to rest of the program. So they act as a black box. Right? Now, there is another program P2, and let us say it needs the function F1, F3 and F4. Right? Since F1 and F3 exist independently, so the same function will be called by the second program instead of writing their code again. You see, this is the actual advantage of using function. Reusability of code. So your C, with the help of function, supports reusability of code. Also, the length, the size of the code decreases significantly. We are just invoking a function instead of writing the entire line of code. Right? In this slide, I have compiled all the advantages of function we have seen so far. Like it supports the modular programming. Use of function improves the reusability of code. It reduces the size of code, improves readability of code, and easy to test and debug the code. Right? The types of functions. In the previous example, we have used the functions which was already existing. Right? Such functions are known as library functions. They have their definition already written by developers. We just call them whenever we need to use them. Like printf, scanf. You all must have used these functions in your earlier program, right? These are the library functions which are written in stdio, standard input output header file. So how we use them? We call them within our program as many times as we want, and we include stdio header file at the beginning of program, right? So the compiler can take necessary information regarding these functions from the header file. Another category of function, another type of function are user-defined functions. User can create their own function depending upon the program they are writing, depending upon their requirement. They are also known as built-in functions. We will shortly see how to create our own function. User can decide the name of the function, right? They can change the name of the function. They can write the functionality of the function on its own. Clear? Elements of the user-defined functions. Your three important elements are function definition, function call, function declaration, also known as function prototype. We now discuss each one of them sequentially. Function definition, right? This is the syntax of function definition, the first two lines written. Now, your first line is known as function header. It comprises of the return type, function name, and parameter list. Now, the return type is optional. The function may or may not return any value, right? Now, return type is a data type of the value the function returns to the calling part, right? Now, function name. User can choose any name, but it should be a valid C identifier. Normally, the name is given according to the task performed by the function. For example, if a function adds two numbers, we may call that function as add. Right? Now, next part is the parameter list, also known as the formal parameters. It declares the variable that will receive the data sent by calling program. We will discuss this in detail in the next slide. Right? So next is your body of function. Right? It consists of the single or multiple statements which perform a specific task. Now this body of function is a mandatory part of the function. However, the function may or may not return a return type. That means return type is optional. And parameters. The function may or may not have some parameters, right? So these two parts, the parameter list and return type are optional. However, the body of function is a mandatory part of a function. Clear? Let us look at this example. Here we have a program main, right, that creates and invoke a function to add three numbers. So we have included a function definition here, which is after the main, right, outside the main. Your yellow box denotes the function definition. It has return type, the name of the function, and formal parameters. Right? Return type is int. That means this function is going to return a value of type integer. Right? The name of the function is add. Right? And your list, the formal parameter list includes three variables a, b, c of type integer. Right? That means these values are being passed from your calling part. From the main, the values of these are given to this add function. Right? Within the body of the function, you have declared one more local variable sum, and then you are adding these three variables and returning that sum to the calling part. Right? So this function is taking the value of ABC. Right? It is calculating the sum of these three values and returning this value to the main. Right? So this is your function definition. Clear? Now, within the main, we have included one variable result. The result will store the value what sum is going to return. Right? And then we are calling a function. Now, this is a function call. The name of the function, within the bracket, you are writing the actual arguments. Right? In this case, I have written 10, 20, 30. That means these values, 10 is copied to A, 20 is copied to B, and similarly 30 is going to copied in C. That means your A will be assigned a value 10, B will be assigned a value 20, and C will be assigned a value 30. Right? And then we are adding these three values, and the sum, that will be 60, is returned to the main program. So in the result variable, the value 60 is stored. This is how a function works. Whenever the compiler sees the function call, that is add, right, it will immediately jump to the function. And once the function is completed, receives a return statement, right, it will jump back to the calling part. Clear? So what we have learned till now, we have seen the function definition. Function definition comprises of function header, that is return type, name of the function, and the formal parameters. In this case, they are A, B, and C. And then you have written the body of the function. Clear? Now this is returning some value. So we have written a return statement, and this value is returned and stored in some variable in the main program. Right? Next, we have seen the function call. Now function call is nothing but the name of the function. Then within a bracket, you are including the actual values, right, on which the operation is to be performed. So these are known as actual arguments. Right? So it should be clear the difference between the formal arguments, the formal parameters, and the actual arguments should be clear. Arguments or parameters, I can say, right? So in this particular example, the formal parameters are A, B, C, and actual arguments are 10, 20, 30. Clear? So these terminology should be clear to you. There are two different ways of calling a function argument, depending upon how actual parameters are passed. Let us first understand call by value method with the help of an example, right? So here I have included one function swap. The function definition is written before main, right? Now what the swap will do, it will interchange the value of num1 and num2 with the help of the third variable, which is called temp, right? So num1, you can see here, we have declared a temp here within a function, and then num1 is assigned num1. The value of num1 is given to temp. Num1 is assigned the value of num2, and finally the num2 will be given the value of num1. Clear? So we have interchanged the value of num1 and num2, and then we are printing these values. Clear? Now, in the main, what we are doing, we have declared the two variables var1 and var2. Var1 is given a value 35, var2 is assigned a value 45. Now, we are displaying this value, clear? And then we are calling the function swap. What we are passing? We are passing the variable name, var1 and var2. That means whenever we are writing the variable name, what does it signify? The value. That means 35 and 45 are being passed here, right? The function is called, so the control will jump to the function definition. Now these statements will be executed. How? 35. The num1 will be assigned a value 35. Num2 will be assigned a value 45. And then the interchange of these two values will be done. Clear? And then after this function call, we are printing the values of var1 and var2. Now important point to understand is this var1, var2 and num1, num2 are different. They are not the same. You cannot say the var1 is same as num1. No. The var1 and num1 are having the same value, but they are different variables. Right? So the value of var1 is copied to the num1. The value of var1, that is 35, is copied to num1. So num1 is having a value 35. Num1 and var1 are different, right? We are calling this type of function call as call by value. Why? Because we are passing the value of the variables here. So a copy is being generated, right? Not the variable. Clear? So what output I am going to get? Before swapping, var1 and var2 will have the value 35 and 45, right? Now the function will be called. Inside the function, yes, num1 and num2 will interchange their values. So I will get 45 and then 35. Clear? But after that, again I am displaying the value of var1 and var2, which are not being changed. Swap is only going to interchange the values of num1 and num2, not var1 and var2. They are different variables, right? So they will retain their values as it is. Clear? This is call by value. Whenever you are calling a function, you are passing the value of the variable. So a copy is being generated and all the work is done on these copies. So actual variables remain unchanged. Clear? Now, before we discuss second method of calling a function, that is call by reference, let us first understand the basic concept of pointers. Now, the ampersand stands for address of. It is a unary operator. Wherever you see asterisk, read as value at address of. Now, let us say if we have written a C statement int a equal to 12, right? Now, what does that mean? This means we are declaring a variable a of type integer and assigning it a value of 12. Right? Now, whenever we are assigning some value, that means we need some memory address to store that value. Clear? Now, look at the diagram at the right side. These blue boxes denote the memory cells. So, let us say the A is assigned a value 12 and the memory allotted at the location 2000. How to check that value? Write down ampersand A, right? So if we are printing that value, we will get the address where the 12 number is stored, right? Now, how to store this address, 2000? We need a pointer for that, right? So we write down int asterisk p. That means we are declaring p as a pointer. Now, the pointers are the special variables which stores the address of a variable, right? Now this p is assigned a value ampersand a. That means p is assigned the value address of a. That is 2000. Clear? And what does asterisk p denotes then? It denotes the value at the address of p. That is value at 2000. That is 12. Right? Yeah, so asterisk p is the value at address of A because p is storing the address of A. So value at 2000 is 12. So this asterisk stands for value at address and percent stands for address of. Clear? Let us understand the call by reference with the help of an example. What I have done, I have included a swap function which will interchange the values, right? And we will start with main first. In the main, I have declared two variables, var1, var2. var1 is assigned a value 35, var2 is assigned a value 45, right? And then we are displaying their values. So we will get the output as var1 is equal to 35, var2 is equal to 45. Then the function is being called here. Now the difference you can see here is instead of var1, I am passing the address of var1. Ampersand stands for address of, right? So whatever address in the memory the var1 is, right, that is being passed. 2000 is being passed here, right, to the swap function. And similarly for var2, I can see here 9456. So this value is being passed here. This is the call by reference. The reference of the variable is passed, right? Earlier we have seen the call by value. So we were just passing the value of the variable, that is var1 and var2, 35 and 45, right? So in this particular case, we are passing the address of the variable, 2009,456. Now, we know to store this address, what we need? We need the pointers, right? I cannot store a variable address into a normal variable. What I need is pointers. So this is how I am declaring a pointer num1 and num2 as a pointer of type integer. Right? Now what we are doing? We have declaring a temporary variable temp. Now temp is assigned the value of num1. What is this num1? The value at address of this. The value at address stored in num1. That means the value at 2000. Now what is the value at 2000? 35. Clear? So temp is assigned a value 35. Similarly, the value at 2000, that means this particular location, memory location. What value I am storing here? The value at num2, right? So 45 is stored at this location in the memory. That means This location is for the variable var1. That means now I am changing the variable 1 through the use of pointers. Clear? And similarly, the num2 value is assigned the value of 10. Clear? 35. So this here it will be 35, here it will be 45. Directly the memory location, right? The memory cell, the value at those location will be changed when we are calling by reference. A function is called by reference, passing the reference of a variable, passing the address of the variable. Now if I am calling printf after swap at line number 11, what value I will get? 45 and 35. The values will get swapped. Clear? Now, the last element of user-defined function is function declaration or function prototype. Right? Function declaration tells the compiler about a function name. Whatever example we have seen earlier, in those examples, I have written a function definition before main. Right? So there is no need to include a function declaration. Normally, the function definition is written after the main, right? So, in those particular cases, we have to include this function declaration above the main, just after your header files. This will tell a compiler that this particular function is going to come in future, right? So, what all is included in function declaration? We write down a return type, the function name, and the parameter list. The first line, the function header, which we have included in function definition, right? The same thing has to be written here. Now, let us say the example, int add int a, b, and c, and then followed by the semicolon. I may also write as int comma int comma int. That means the compiler is only interested in the number of variables and the data type of variables which are there in parameters list, right? So the name is optional. You may omit this variable name, you may include these variable name, right? So now your structure of the program will be the header file, function declaration, then the main. After that you are writing a function definition. Clear? Now these are the references I've used. So certain concepts I have covered in this part of presentation, right? The leftover is covered in the second part of the function presentation, right? Wishing you all a very happy learning. Thank you.